See in this example, when two resistance wires are in the two gaps of a meter bridge, the balancing point was found to be 1 upon 3 meter from the zero end. When a 6 ohm coil is connected in series with the smaller of the two resistance, the balancing point is shifted to 2 upon 3 meter from the same end. Now, find the resistance of the two wires. Suppose you have got a meter bridge wire like this, whose length is A and B, this is of 1 meter. It is connected here by the cell here of EMF, and key K is connected here, and between this gap there is a one gap where the resistance R is connected, and another gap is also here where the resistance S is connected. Between this one a galvanometer is connected here, suppose, and another end of the galvanometer is connected to the jockey. So, and here we can take R is less than S. So, when R is less than S and balancing length is obtained in this situation, so it is something here, somewhere here 1 upon 3 meter. So, L is here and this is here 100 minus L, that is called 1 minus L. So, in the first case it is given here L is equal to 1 upon 3 meter. So, according to the Wheatstone bridge principle, we can write R upon S is equal to here L upon 100 minus L, and we can write 1 upon 3 upon 100 is 1 meter minus 1 upon 3. So, we will be getting R upon S is equal to here 1 upon 3 upon 2 upon 3, this will get cancelled and we will be getting 1 by 2. So, we can write here S is equal to 2R. So, from the first case we have got the value of S, that is equal to 2R. So, now in second part, one resistance of 6 ohm, here in the question it is said here, when a 6 ohm coil is connected in series with the smaller value of the resistance, R has the smaller value of resistance. So, now if you are connecting one resistance with this R in the 6 ohm, then this R will become here now R plus 6 divided by S is equal to, now the balancing length is shifted to 2 upon 3. So, 2 upon 3 upon 1 minus 2 upon 3, that we will be getting here only 2. So, we can write, already we have calculated the value of R in the first case, that is here 2R plus 6, that is S is equal to, we have calculated. So, we can write here R plus 6 upon, that is here 2R is equal to 2. So, we can write here R plus 6 is equal to here, that is 4R. So, we can write 6 is equal to 3R. So, R is equal to 2 ohm. So, we have got the value of R. So, the value of this resistance is 2 ohm. Now, we have to get the value of S. So, we will replace in this one. R is already we have calculated 2. So, S will be here 4 ohm. So, this question is actually based on the meter bridge, which is actually based on the principle of Wheatstone bridge.